This little video is just to do an introduction to the vocabulary used in sequences and series. Okay? And these are the main words that I'm going to be talking about. So first off, I want to talk about sequences and series and what the word term means. I'll start by giving an example. Oops, I didn't mean to do that. Alrighty, give an example. Okay, a sequence can be something like 2, 5, 8, and I might put ... And this is a list of numbers. And in this particular example, they're being the next term from the one in front of it is different by 3. The 3 dots, ellipses, indicate that it's going to go on for infinity. So a sequence is actually just a list of numbers, okay? So just think of it as a list. And you're going to see commas in a sequence, all right? Another example could be something like 10, 5, 0, -5. A sequence can it can go up, it can get bigger, and it can also go down, all right? So just in both cases, those were lists and they had commas. A term, well, let me skip term for right now. Let me move on to the definition of series, or an example for a series. This is the one that I think is a little more confusing because to me the word series sounds like a list. That's what I think of when I hear the word series, but it actually means the sum of the numbers in the list, all right? And if you've ever used Excel, you might have noticed this little button at the top. It kind of looks like this, and that's called a sigma. And what that represents is the symbol for a sum. And if you use Excel, you press this button at the top, and it's going to give you the sum of a row or a column. So let me give you an example of a series. Oh, actually, I can't really give you an example, but I can do the total. The total, let's say I stopped this sequence at 2, 5, 8, and I just stopped there and had 3 numbers in it. The actual series would be 2 plus 5 plus 8. Well, 2 plus 5 is 7, 7 plus 5 is 15. So the series would be just 15. In the bottom here, I've got a 10, 5, 0, -5, no ellipses. So if I was going to total that up, I'd have 10 plus 5, which is 15, and a -5 is 10. The series would be the sum of those 4 numbers. Now, it's possible to have a finite series, where you indicate a stopping point, or basically what you're doing is you're going to indicate how many terms there will be, or you can have an infinite series. And it's also possible that your series can have a total, or it may not have a total. If it's infinite, it may not have a total. Okay, so let's go back to the word term. A term means the item in the list. So each one of these, the 2, the 5, and the 8, they're all terms. And when we refer to terms, we can talk about something like the nth term, and we would replace the n with a number. So I might call it the 10th term, for example, where n was equal to 10. I could call it the 8th term, all right? And we'll be using that word and the n in some formulas in a little bit. Now, next, I want to just briefly talk about 2 different types of sequences and series. So these 2 words, arithmetic and geometric, can be used in front of the word sequence and series. So there's actually 2 types of sequences, 2 types of series. In arithmetic, we're really talking about adding something to a prior number or prior term. So the 2 examples that I gave, 2, 5, 8, and 10, 5, 0, -5, those are actually both examples of arithmetic because I'm actually adding a number to the prior term. In the first one, when I go from 2 to 5, and then from 5 to 8, I'm adding 3. In the second one, when I go from 10 to 5, 5 to 0, and 0 to -5, I'm actually adding a -5. So you are adding a common difference. All right? And that's what makes arithmetic. All right? We're going to be using the letter D to represent the common difference in the formulas. So that makes kind of sense. D goes with difference. In geometric, we're actually talking about a common ratio. And we are actually going to be multiplying the prior term by this common ratio to get the next term. Let me give you one example.